So this question is a little bit more complicated. First, we'll do our givens. And so to fit my entire solution in this, I'm going to have to write, at least attempt to write kind of small. So the applied force is 15 newtons, and the mass is 3.9 kg, with the coefficient of kinetic friction. Oh, sorry. Here you go. With the coefficient of kinetic friction being 0.25. With the initial velocity, so it starts off at 0 meters per second, and then traveling 12 meters. The question is asking us to find the final velocity. So how would we solve this question? First up, we know that energy is not conserved, mainly because there is also friction acting. So if we were to make a free body diagram for this, it would look a little something like this. So we have a box, and then we have the force applied, just acting, let's say, in this direction. And we also have the friction, which acts in the opposite direction. And so if you were to write the net force for this, F net is equal to force applied plus the kinetic friction. And then to get rid of these vector arrows, force applied minus the kinetic friction. All right. And so we can simply solve for the net force. So let's do that right now. So we have the force applied, which is 15 minus Fk. So if you remember, the equation for the friction, the kinetic friction, is the coefficient into the mass, finally into gravity. So we can rewrite it as 15 minus 0.25 into 3.9 into 9.8. And if you were to solve all of this, it should give you 5.445 newtons. And so now that we have this solved, we can use work and kinetic energy in order to solve for the rest. So how are we going to find the final velocity? Well, we know work is equal to the change in kinetic energy. And we know work is F net into delta D, and the change in kinetic energy is 1/2 the final velocity squared minus 1/2 the initial velocity squared. Now we know that the initial velocity is 0 meters per second. And so if we were to plug in 0 meters per second here, then that would make this entire part 0. So we can simply cancel this out, and we are left with F net into the change of displacement into 1/2 mv squared, or the final velocity squared. Simply, we can plug in everything we know here and here, and we can find the final velocity. So 5.445 into 12, which is equal to 0.5 into 3.9 into the final velocity squared. And so on the left side over here, we have 65.34. On the right side, 1.95 into VX squared, and then we're going to divide both sides by 1.95, which gives us 33.5 into final velocity squared. Lastly, all we have to do is root both sides. Once we do that, we get the final velocity, which is 5.788. Now just take a look at the significant digits. 2, 2, 2 over here, so we only need 2. Therefore, final velocity of the object is 5.8 meters per second. And so that is how you solve a question like that.